Hello, guys. Welcome back once again to to today's live session. Please drop a comment in comment box if you can hear me. Um, so today I'm like 30 minutes late, so I had to do a couple of things, and I couldn't meet up to the time that I had set. But I was still able to find my way and you know come for this very live session. So please, if you can hear me, please consider dropping a message in the chat box so that I can proceed. Thank you. All right. So all right. So so today we are going to be looking at basically mainly the we're going to be looking at custom types in Rust. Right. So we're going to be going from structures to enums, and then we'll talk about the use declaration, um, C types, C like types of enums. Um, I would have actually gone ahead to implement like a linked list in this particular session, but I wouldn't be doing that. And the reason for that is because um, I want that to be like a subject entirely of its own, right? Something that will really drill deep into to understand the concepts of what it is about. So I wouldn't really go into implementing a linked list in this very in today's session. But I will talk about structures, enums, and constants in the Rust programming language. So once again, say thank you for um, joining me on this one, and let's let's get into it. So um, first off, what are structs, right? So um, we call them structs, right? That is short form for structures. So structs are, they're super versatile, um, and they basically help us to make our code clean and organized, right? Um, so basically, the structs are a way in which we can group multiple values together into one unit, and we can think of them as a custom data type where you define what field it contains. So this allows us to, it allows us to work with more structured and meaningful data, right? When it comes to structs. Um, so without wasting much time on the theory, we just go over to VS Code and start writing some code. All right. So here in VS Code, um, we'll declare. So there are types of there are three main types of structs. So we have the tuple struct, we have the classic struct, and we have the unit um, kind of struct, right? So guys, please confirm if you can hear me. If you can hear me, please drop a comment. Consider sharing the live session so that other people can join. Please, if you can hear me, so that I can continue. All right. Thanks. I really appreciate that. Okay. So, as I was saying, there are three main types of structs. So we have the tuple struct, we have the classic structs, and we have the unit structs. So, I would in this very session, I would just go ahead and explain these things. So basically, what we are looking at today is just the basics of the language, right? So we're not building any fun project like we did yesterday, where we built an algorithm for a music player playlist and all that. And so today is just beginner concepts about the language and all that. And today we are looking at custom types for those that are just joining the session. So now, um, how do we define like a tuple struct? Basically, in Rust, the tuple struct allows us to group related data, but don't give names to the field, right? So an example of this is this. So add a comment tuple struct, and of course we'll use the keyword, the struct keyword, and I'll call this pair, right? So I would want to pair integers, an integer and a um, a float, right? So um, I would say I32 and F32, right? So this is an example of a tuple struct. Now let's go over to a classic struct. I'll add a comment for a classic struct, and in this classic struct, um, these are usually you know similar to languages like C and C++, right? So they are common. They are the common types of structs we see in those languages, and I think they are more. They are even more common in the Rust programming language. So basically, in most code bases, you would see people define structs like this, and it's basically using the same struct keyword. So I would say this is a person, and a person would have a name. So the name would be a string. It doesn't have age, which is an integer. So I will just give it a type of U8, right? So these are classic struct, and they are similar to languages, similar to how it's done in languages like C++ and um, and C. Then finally we have um, the unit structs. So these are fieldless structs. They are usually very useful for generic traits or markers, something like that, things like that. And the way we define them is I'll add a comment, say unit structs, and struct, let's call it units. That spelling is not correct. Exactly. So we have this. Right? So this is how we, um, you know, this is how we define unit struct. So the reason we have this warning is because we define these things and we are not yet using them, right? So we'd have these warnings from my Rust analyzer. So it kind of shows me where the possible issues, and I have to so basically just overlook them. They wouldn't affect anything that we are doing. So now let's look at some code examples. So creating a classic struct, how do we get to use this our classic struct, right? What we have on line 6 through 9, through line 9, right? How do we get to use it? So in order for us to use it, first of all, delete this line. So the print line, um, so we would create a new person, right? We'll initiate or instantiate a new person. So at the comments, create a new person. Okay, guys, sorry for the little break in transmission. So please, guys, confirm if you can see me. I don't know. I didn't know my don't know. You guys can if my camera is on or something. Please let me know in the comment section. If anyone can hear me, please let me know too. I went silent for a moment. So um, moving forward, we're going to create a new person using the classic struct, right? So first thing we'll do is we'll say we want to add a value for the name that we have in our struct. We know that the name itself, in of itself, has is a type of string, right? It's a type of string. So what we'll do is we'll say let name, so let name be equal to string new, and in that place we'll pass a name. Let's say Mike, right? So we'll pass that name into that place. Then string person. Okay. So next we'll also define the age. So say age, and our age will just it's an integer, so 27. Give the person the age of 27. Mm. Then we'll then use these two values that we've declared in our person struct, right? So we'll say let's Mike, so the person's name is Mike, be equal to our person, the person struct. So we'll call person, and then we'll have curly brackets, and we'll pass the name and the age into it, right? Exactly. So we'll save this and yep, string dot person. So next, let's try and print what we have to the console. So print, I'll just say print the person struct, and so here would use the print line statement. So print line, and in that place we'll just do the formatting stuff, and we'll pass Mike into that place. Right. Okay. So person doesn't implement the debug trait. So in order for us to be able to um, log the you know the person struct to the terminal or print it to the terminal, we have to there's something called derive debug, right? So I come back here and let me come down here. There's a derive debug. So all these things are basically in the documentations, right? So I can, you know, there are a lot of this, but I can just take this. So something like this, right? Enables us to be able to print or yeah to print to the terminal. So we'll take that line of code, go back to this place, and here at the top here, we'll add that guy and we'll save. So that should solve our first bug. Then the second bug says this function takes zero argument, but one argument was supplied. Okay. Um we'll figure out why that happens. But now we have a string. Okay. Not string dot new, string dot from instead of new. So this should fix that issue. Exactly. The field name and all that. So for the rest of the code, I will just go ahead and add the derived debug on it. So we don't have those weird errors. Same here. Save. Mm, okay. And also we can add like dead code, right? So there's something they call dead code, right? So that's take away those errors. Micro dead code. Let me check the documentation. Dead code. Yeah, so allow dead code. Okay. So because I don't want to be seeing those errors. So I'll take this guy, come back here, comment out this line, add dead code, and also do that for this. So add here. I'll save. So with this, I should have a cleaner business. So fields name and age I never read. Okay. Person on drive implementation trade blah 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 blah. Ignore dead code. Ignore during analysis. Okay. So that's not like our main focus, but I'll just go ahead and cargo run. So as you can see, in the terminal I have the name and the age, right, which I had passed on line 21 and line 22. Then I kind of like destructured it into the person struct, which we have defined here, right? And we're able to, print that to the terminal, itself. So basically, what we did here, we used the formatter, so the debug formatter to print the values of the struct to the console. We're able to do that because we added this value here, the derived debug, and the derived debug enables us to be able to print the struct to our terminal. So I'll clear that and we'll move forward. So next, we'll look at how we can instantiating and using structs. Um, we can use structs for more complex data, more complex ways. So let's look at how we can create a more complex struct called point, and then this point is going to take like floats, right? F32s of y and x and y axes, and we're going to use that to do something as we go on. So first off, what we'll do is we'll define a struct and call it point. And this point struct will take an x, which is a type of F32, and y type of F32. Right? All right. So now in our main function, what we can do is we can say we can initiate a new point. So init a new point, and similar to what we did with the name, right? We'll do something similar to that. So we'll say let point. So let point be equals to point, which is the name of our struct, and in there we'll say x would be equal to 1.9 and y would be 3.2, something like that. Yeah. So now we have initiated a new we've initiated a new point with values in it. So now we can go ahead to assess the field, right? You can say assessing the fields in our points. So here we can print line, print line. So in there, I don't just want to um print the point to the terminal, right? I want to be able to access the points individually using the dot notation, right? So what I would do here, I'll add a better comment. So I would say point coordinates. So I'll just put it like that, and so I'll have like a better formatting for this. Open bracket, space, and cover it up. So in order for me to get the x-axis, I'll do point dot x, right? Oh, what's happening? So point dot x, and similar, I can do point y. And when I save this, I'll comment out this line, so we have a clean terminal, and I'll run this code. Let me comment out everything here. So I want my terminal to be clean. Okay, then I'll run the code again. Cargo run. Exactly. So you can already see that in my terminal, I have the point coordinates here. So 1.9 and 3.2, which are declared here. I've been able to, print them on this line, right? So basically what I did here is to use the dot notation to assess the x and the y axis of the point struct. So then we have another thing that we can do. We can actually update our struct, so that is um, you know, a syntax that we can use to update the struct. So what I can do now is I can say, I'll say let another point. So let another point, and I would say let it be equal to the same point struct, right? And now I would then say let x in this point, let it be, so initially our x was 1.9, right? Our x was 1.9. So now I'll change it to let me say 10.3, and yeah, so I'll then pass the rest of the points into the struct, right? So basically what I'm saying here is just like spreading, an array, JavaScript, something like that, similar to that. So here I'll just add point itself, and I should be fine, right? So if I go ahead and I try to print, so I'm going to comment out this line, or I'll undo that, copy it, then comment it out. I'll paste it here. Okay, so now in order for me to be able to get the values of my points, right? What I'll do at this point is I would, instead of using point, I'll use another point, right? So I'll use another point dot x. And what will happen at this point is when I do another point dot x, I will get 10.3. And when I do another point dot y, because I just added the entire struct and the value into where we kind of where we are trying to update the syntax, I will get the previous value of y because I did not update that. So when I save this, and I'll save this and run the code. All right, so let me zoom a little bit into this. Exactly. So you can already see that we had updated this. So initially, um, here we had 1.9. So the first time we added value to our point struct, we had 1.9 as the x coordinate. Now we've updated it with 10.3 by updating um, that particular um, syntax. All right. So next, we are going to look at how we can work with even more complex um, structs. Yeah, so Erimus is also live on YouTube. I wonder why the video quality is poor on X. I'm very sorry about that, but this is also live on YouTube. I wonder why that is happening on X. But thanks for calling that to my attention. Yeah, but this is also live on YouTube. So live on YouTube. Anyways, let's move on. So next, we are going to look at how to work with even more complex um, structs, right? So in this case, I'm now going to use the points, like the different points, to create a rectangle. You know that a rectangle has how many sides? Four sides, right? So we're going to use these points to. Okay, thank you so much. So we're going to use these points to create a rectangle, and so what I'm trying to do here is I'm trying to go deeper and deeper into the whole thing to kind of like explain how complex structs can get and how we can use them in um, to solve different problems, right? So I will just clear this and once again, so because I'll be using the point struct, um, I would go ahead and create another struct. So I'll call this struct and I'll call it rectangle. So it's rectangle, and there I'll have the top left, and for the top left, I would just pass the point to it, right? Because it would have both x and y axis. So for the top left, pass points, and for the bottom right, I also pass points to it, right? So now, how are we going to use this? How are we going to use this guy in our main function? So once again, I'll comment out everything here, so it doesn't affect what we are doing. So here, I'm going to declare a value for the top left, right? So I'll say let the top left, let it be equal to point. Remember, right? If you can remember, we passed the point struct to our rectangle struct. So you can begin to see how we can nest structs in other structs and how we can use them to achieve the desired goal, right? So now we say points, and we know that in the point struct we have the x and the y axis, and the x and the y axis are both floats, right, of type F32. So we would have to pass values to them, right? So what we'll do at this point is what we've always done. So we say x and we give this 1.5, and y we give it 2.5, right? Then we'll close it off with a semicolon. We'll do the same thing for the bottom right. So there we'll also declare okay, our points, and for the x-axis we'll give it a value of 5.0, and for the y-axis we'll give it a value of 20.1. Close it up. So now we have we've we've passed values to that. So this is top left, not top left. It should be top left. Yeah, left, and so now we are now going to go ahead and say let's rectangle angle be equal to, so let it be equals to rectangle, and then yeah, that's actually correct. So I don't know why um this thing keeps trying to write the code for me. So left top left, and we have our bottom right. um Work, then add the semicolon, save. Now we've declared our struct. So basically, we've passed value into our struct, right? We have the rectangle, and this spelling is not even correct. So I'll just copy this and pass it here. So bottom right, no such field as bottom, not bottom. So little typographical errors. Save, cannot find struct variants. Okay. So we yeah, okay. So that's corrected. So we'll go ahead and print line, go ahead and print line. And in there, um first thing we'll do is we'll, you know, so I'm going to try as much as possible to add strings to kind of explain um the the various parts of the rectangle. So the first part would say rect, because to type that in out is it's going to be hard. Rect rectangle corners, so that's short for it. Rectangle corners, so top left. I'm here going to pass this space. Mhm. Then comma. So for the bottom right, we're going to do the same thing, right? So the same thing, we have bottom right, and we have those two values. Then it is time for us to, declare them. So we say rectangle dot top left, right? Is it top? No, rectangle dot top left, because we want to get everything in the top left. So we say top left dot x, right? We'll do the same thing for the y-axis, right? So I'll just add a comma, copy this, paste it here, change it to dot y. So we've gotten the rectangle corner. So for the top corner of the rectangle, and the next we'll also do that the same thing for the bottom side, right? For the rectangle bottom right, we'll get the x and the y axis. Okay, so around that comma, I'll say rectangle. Well, I'll just paste this. Now delete. So I know that in my rectangle I have the bottom right and the top left. I've attended to the top left. So next I'm now going to go to the bottom right, dot x axis, and then I'll also do that again. Then go to the bottom right dot y axis. So if you want the code in VS Code, if you want your code to wrap, if you're on a MacBook, you can do Option Z, and it would wrap the code for you around like this, the way I have it here. So if I save this and I print, so if I print this to my terminal, for the top left, I'm going to have 1.5, and for the um, for the top for the top left x axis, I'm going to have 1.5. For the top left y axis, I'm going to have 2.5. For the bottom right x axis, I'm going to have 5.0, and for the bottom right y axis, I'm going to have 20.1. Right. So if I run this code, should have should have those values exactly. So for the top right, I have 1.5 and 2.5, which is what I had declared here. And for the bottom right, I should have 5.0 and 20.1, what I've declared here. So what makes this different from what we have done before? So what makes this different is that we have a struct in a struct, right? And we're able to add values to a struct in a struct and go ahead to get those values and print it. So basically, right, we had our point, and for every point we have like an x and the y axis that takes a float of f32. Then we went ahead to create another rectangle struct that has a top left and a bottom right, and it took the point as the value to the keys in our struct, right? Then we were able to pass, for the top right, for the top left, we were able to pass values, which is points at x and y axis. Same for the bottom right. And then after declaring this, we then passed it into our rectangle struct. right? So then we're able to use it. So you can begin to see how we can gradually build on these concepts to kind of achieve what we want to achieve. So we can go as crazy as possible with this, right? So moving forward, we'll then look at the structuring and pattern matching. You know, in structs. So Rust allows us to destructure structs. So basically, destructuring is a way that we extract individual fields, right? Um, so an example of this is I will still use the point. I'll still use the point as an example. So we can say, I'll comment out this. I would say, comment on this, and I'll add a comment somewhere here. This structuring, structs. So here, we already have our point, our point, or so what is going to happen is at this point, I am going to kind of like uncomment one of these our points and you know use it for what we're trying to achieve, right? So in this case, I'm going to uncomment. Which one am I going to uncomment? Let me see if I'll uncomment this guy. Hmm. Anyways, let's just go on. Right. So we can say let's point, or even before that, we can yeah, actually. Um hmm, trying to think, trying to think. So if we go back to like the documentation, right? And then we go to custom types, go to structures, and we scroll down. Let's take a look at how they did the structuring. Hmm. So point. Okay, so there was already a point declared here, right? So we're now able to, you know, initiate it here and then destructure it, kind of like object destructuring, right? So we're then able to, um, use it here in the rectangle. So we have left edge, top edge, which was defined here. So basically swapped the actual x and the actual variable or name for that particular value to left edge and top edge basically. Okay. So let's give this a try, right? So first off, we have to do something like this, right? So we have to, wait some time. We had something like this in the code. So here at point, so I'll comment that out. So in order for us to destructure that point value, in order for us to destructure it, we would first of all say point, and we can say let's point. We can say let point be equal to something, right? Equals to that point. So now instead of just leaving it like so, we're going to do our destructuring, and there we know that we have x and y axis in our points, right? Sorry, in this place. So we'd say x, um, name it left edge edge, and y we'll call it um top edge top edge, right? So you can automatically see that they are both type of F32s, right? Because if you remember, in Rust, F32, you know, floats, which have like what was it called, decimals, right? So 1 point, anything that has like a point something, right? So but this particular stuff that is here is defined by the package I'm using in my code environment. So this might not be the case for you when you're doing this if you decide to do this, right? So what I can do is I can go ahead to add it manually. I can say F32, right? And I can also do same for this. Should be able to do that. Oh, Let me say expected comma. Hmm. For some reason I can't do that. But my Rust analyzer shows me that this is a type of F32, and of course, anything that has a point something, is a floating type, and it is a has it. We have two types of floats. We have the F32s and the F64s, right? So without dwelling much on that, we just go ahead and print this to the terminal. So say print. So in this case, we left edge, left the GE, the left edge. Mhm. Here I would call it and we would also have like our top edge, maybe top EG, G. Let me change this to capital letter. Okay, so now we'll then pass our left edge and left edge and top edge. So when we run this, and we look at go run, we should be able to see those values. So go run. So we can already see those values. You can see that the top edge, the left edge is 1.9, which is here, and the top edge is 3.2, which is this. So we've changed, we've changed it. So we've destructured it and given it a new variable name, right? So the name of top edge and left edge, which is what we eventually used here and here. So this is how one way we can destructure structs. We can also destructure struct tuples, right? So we can say, for instance, where we had we can so remember when I defined a tuple, right? So this is where I defined a tuple of type um, F32 and I32. So we're going to use that tuple, and then we're going to use it here. Mm. So we're going to use it here. So we'd say so okay, I'll add a comment here so that we can differentiate it. The structuring struct tuples. Structuring a struct tuple. So in this case, we say let the pair. Remember, we had initially created a tuple. So we say let the pair be equal to our struct that we have at the top. So pair, which has type of I32 and F32. That is this guy. So an I32 is an integer. It's just a normal number. So remember that tuples do not take any so they don't take any name. It's just normal values in them. So we'll pass 10 here, and the next one will be 19. Then next one will be 2.6, right? So we've this is a struct tuple. So next, what we are going to do is that we are going to destructure this. So in order to do that, we'll say let's pair be equal to. So we'll give them names, right? We know that one is an integer and the other one is a decimal. So the first one is an integer, which is an integer of 10. So we'll say this guy is an integer, and the other guy is a decimal because it is a point something, and we'll then equate it to our pair, right? So pair, say pair. At the end of the day, we'll print it to the terminal. So we'll say print line, and there would say the pair contains. So pair contains the first one and second one. So here we'll just pass our integer and decimal, right? So I'll comment out this line for the structuring the struct. So I would have a clean um, one of the, so I'll have a clean log. I'll clear this and I'll run cargo run again. Exactly. So you can see that it says the pair contains 10 and 2.6. Right. So this is how we can also destructure tuples. So if you remember, I said enum structs have three types of there are three types of structs, right? So we have the tuple struct, classic struct, and the unit struct, right? So I had initially defined them here at the top. So we have the tuple structs, we have the classic ones from languages like C and C++, and we have the you know the um, unit structs. So yeah, that's that. So next we are going to move over to enums. So if you remember, I mentioned that we are looking at custom types in Rust. So we are going to move over to enums, right? So basically, um, enum in of itself, it's a keyword that allows us to define a type that can be of few different variants, right? So each variant can hold different types of data. So you can think of enums as a way to group related values together, and what this does is that it makes the code more expressive, and at the end of it, it makes it more um, type type safe, right? So without talking too much, I'll just go ahead and comment out everything that we've done for structs, and we'll start with enums, right? So here I would also comment out all this, and I will leave the main function, and here I will just call this enum. And in order for us to declare or define an enum, we use the enum keyword. So small letter EUNM. And in this case, for this our example, we are going to declare an enum called web event. And if you're coming from the web, like JavaScript, you know that web events consist of you can have like page load, key press, refresh when you click on something. So for instance, when you press a key, you should expect like a single character, right? Or some characters. When you paste something, you're actually pasting a string like words or paragraphs, right? When you click on something, sorry about that. When you click on something, you should be expecting like a particular coordinate, so an X or a Y, um, you know, coordinates, right? So in this case, and we're going to declare an enum, and we'll call this enum a web event. So web event. So the enum contains different web events, right? So now in here I would have like a page load. I'm going to have a page unload. I'm going to have a key press, mm, and that key press is going to you should expect a character. So then also I'm going to have paste. So accept the string. Then finally, last but not least, I'll have a click. So the click will track the x and y axis on this on the screen. So basically, as I'm moving the mouse, I should be able to track the x and the y axis to the center of where the mouse is. Right. So we're trying to mimic like close to a real world case in this situation. So here I would say x. I'll say x, and I'll give it a type of i64, i64, and y. I'll give it a type of also i64 too. Right. So yeah, right. That's okay. Remove this. Remove this. Yeah. So this is basically how we define enums. in Rust. And like I said before, the enum keyword allows us to define a type that can be of one or or few different variants. Each variant can hold different types of data. So it's a way for us to group related values together. Thereby making our code more expressive and at the end of the day more type safe, right? So we'll go over to how we can define and use enums, right? So as you can see, we've already created like a web event to classify various types of web events. Each variant is unique and hold different data types. As we've seen, you can see that the key press hold the data type of character, and we have a type of string for the paste, and we have type of integers for x and y axis for click, right? So what we are going to do now is in our main function, would let me comment out this line. So would go down. Um, so I think I would just copy this, cut it out, comment out everything that has to do with my struct, just to keep it clean and so that we don't have to scroll a lot. Comment this out, also comment this guy out. And down here, I'll create another main function. So something completely or entirely new or different from, so I'll also comment this out so that we have a very clean working environment without having to scroll a lot. So first thing I'll do, I'll paste my web event. Then next I'll create a new main function. So fn main, I'll just add the normal hello world. Hello, hello world. So yeah, so we have like a new kind of like a new this thing. Um, so that we don't get what we have done before in our structs and corrupted or scattered or something like that. So I'll cut this and take it down here, and I would add comments, and for this part I would call it structs. So everything we did here is for structs. All right. So we have enums and so now we are talking about enums. So back to what I was saying. So next, so guys, please, I've been talking for a while. Please, please, you can share the space, the live session. Help me retweet on Twitter. Drop a comment on YouTube. This is one way you can help me, right? To get more people to um, see the contents, right? Um, okay, guys, please help me drop a comment, please. I really appreciate. I really appreciate that if you do it. Please help me drop a comment. It doesn't take a lot. Um, there are about 77 persons on this live session. Please help me. Thank you. Um, okay. I'm seeing some interesting comments on a group I belong to, so that's why I'm actually laughing. All right, guys, please drop a comment. Please, it's not that hard. Please, thank you. Anyway, so let's continue. All right, so now we've created enums, and from the documentation, right, it says enum. The enum keyword allows the creation of type, which may be one of a few different variants. Any variant which is valid as a struct is also valid as an enum. It's not really explaining. It doesn't really explain what it does, but basically, like I said before, right, is a way for us to hold different types of data, right, in simple terms. So we can classify various types of just like we've done, and various types of web events in this case. It is very similar to what we have in documentation. So it's not like this thing. Anyways, Okay. So now in our main function, what we can do is we can look at ways that we can try to use our enum, right? So one thing we can do is we can say let's um let's page load, or let's just say load, be equal to the web event, which is the enum. And in order for us to get that value, we can see if we use double colon, um we can pick and choose among those um the variants that we've declared in our enum. So in this case, we need the page load, right? So page load. So next we'll go to unload. So let's unload equals to web event dot page unload. We have that. So the next, now we are going to go over to press. So say let pressed, let's say pressed equals to, so web event, the web event, and here we'll call a key press. We'll call the key press, and we know that we're taking a character, right? So a character could be an emoji, a single alphabet, or something. So here we'll just pass something like T, right? The next, we'll talk about paste, right? So we want to paste something. So we say let's pasted, let's pasted equals to web events, and in that web event we'd have our paste. So here we can now say something like we can say um let's say Lauren ipsum dollar, Dolor, and we'll then do to owned, OWN. So to owned is another way of which we can come. It's similar to using to string, right? Similar to it, you know, similar to using to string. Yeah, so we can do that. So we'll do that for the pasted. Then we'll do that. We'll also go ahead and do for click. So say let's click the call to web events dot click. Now in our dot click, we'll then let the x, so the x axis in this case we'll give it 20, and for the y axis we'll give it 80. And yeah, so now before we go on, right, um because what we are doing here is we are looking at how we can, like, we are looking at defining and using enums, right? So we're going to create another function, and in that case we're going to use like pattern matching. So basically we are going to watch out for some specific events, and we are going to do some certain things, right? So I'll create a function called inspect, and this inspect function, we are going to pass each of these events, or each of these events into that function, and we're going to use it to do something there. So basically what I'm trying to show here is I'm trying to show how we could use enums in in actual um sense, or in real world you know examples or something. Okay. So um what we can do here is I'll just go ahead and don't mind all this unused variable code, whatever. So we'll come back to that. So down so for us to use pattern match, so basically what is pattern matching first before I even go ahead and start writing the code. Pattern matching is one of the most powerful ways or powerful features of enums in Rust. So we can use it to handle different variants individually, right? So it's it will make sense when I start writing the code. But basically, we can write a function called inspect, and this function is going to take the web event, and it's kind of like using a switch statement in JavaScript. Is in fact is similar, right? If you're coming from a JavaScript background, using a switch statement. So it's kind of similar to that, where you check for different cases, right? And you carry out certain different actions for each of those cases when they are actually true. Same thing in this case, right? So without like rambling too much about that, I'll just go ahead and write a function and I'll call it inspect, a function called inspect. And like I said, this function is going to take the event, and this event is the web event, right? So the web event, and it's not, so I'll just call it web event. And so in this place, we are now going to use our match. So match, so we are going to pass the events. So we want to check for the respective events, and then we are going to do some stuff here, right? So we are going to say web event page load. So web event dot page load, if it is true and we want to print something to, to the terminal, right? If the web event dot page load is, if it is called, we want to, print something to the terminal. So in this case, say web event dot page load equals to, so we'll just print, just do a simple print line, write this in capital letter, and there we'll say the page loaded, right? So this is for the first this thing. So we are actually getting, okay, page load. What is it saying? Missing match arm. Key press. Oh, okay, paste and okay. So it's basically telling us that we've not covered other arms of this thing. So we are going to gradually get there. So this is for the page for page load. So next we are going to do for page unload. So I would say web events. We have, so this is for page unload, and would still say the same print line, the page unloaded. So guys, I'm using the suggestions from my VS Code because there is no time. I don't want to waste much time. But you get the point. So we can still say web events dot key press, right? Key press, and here, okay, key press, and here we pass, because this takes a value, so a single character, right? We'll say C, and similar to this, print line. So we just print line, and here we would pass the value that was pressed. So pressed, and this, so we would say C. Okay, save that. The next, right, event. This I cannot find web events. Oh, okay, this is not correct. Web events. Save. So next we'll look at the paste. So say web events paste, and we are taking a value too, so we can just say we're taking a value of the different word s, which is a type of a string, and we want to print, and we would say we pasted something, so pasted, and we have this, then we'll pass our s here. So basically in this case, s stands for string and c stands for character. And the last one, last but not the least, is for the click. So web events click. So in our click, we are taking two things, the x and the y, right? So we have undo this, undo. Just write it manually. So here we have our object and our x and our y. And if you remember, we gave both of them um, the a type of I64, right? So if you take a look at line 78, we gave both of them a type of I64. So we then go ahead and say, we'll go ahead and say, so print line. So print line, we want to like show what was clicked, right? So in this case, we say clicked at x, which is equals to open bracket close, and y, which is also going to be, and we're going to pass our x and y, right? This then we'll need our semicolon, need our comma and all, right? So yeah. So basically, what we've done here is that we defined a function called inspect, and that takes the web event, right, as an input based on the variance. So we print at the end of the day, we print the message using like the structuring and all that, right? So the final thing for us to do at this point is to now call the inspect in our main function that we can use it. So we can say inspect. So inspect is going to take um, each of these guys we decline we had defined here. We're going to pass load. So I'll just copy this and duplicate it multiple times. One, two, three, four. Right. So I'll save this and I'll just format the code. So cargo fmt. That should format the code exactly. So now I have load. After load, I will then go ahead and I want unload unload. Sorry about that. Unload. The next one I want pressed pre pressed. The next one I want pasted. And the last but not the least, I want click. Right. So I'll save this exactly. So all our errors have suddenly cleared out. Right. So now I'll clear the terminal and cargo run once again. Let's see what happens. Exactly. So guys, you can now see that we have the page loaded, right? So we are loading it here. The page unloaded. We have the T, the type of T which we passed here. Take a look. Remember the key press takes the value of T. Then we have lorem ipsum, which is which we are basically printing here. So what inspect is doing for us is that it's printing all these things. Then we have the coordinates, which is of x, y, which x is of type 20 and y is of type 18. Right. All this is emanating from our web event enum, holding variants that are similar class but different values and all that. Right. Um, yeah. So this is it. Right. How we can use our enums. So moving forward, there's also we can also talk about type aliases and with enums. So this just forget about the big name. Um, but what this means is you can have like a type alias that replaces a longer name for an enum. And what this means is, for instance, let's say we have another enum. So let's say we have an enum, and this enum is too long, right? Let's just say the name of this enum is Elon Musk is the the richest man on earth today. So we can already begin to see how long this is, right? Or we can use um um a more a name that would more like match what we are trying to achieve, or what we are trying to do here, right? We could use a name. So let's say I have this name written down, so I'll just paste it here. So enum of very verbose enum of things to do with numbers, and this enum is going to take two type of things that we want to do with our numbers. In this case, we would say we want to add our numbers, right? We want to add our numbers. We want to also subtract our numbers. We can also say we want to multiply our numbers. Let me add multiplication. So we want to multiply our numbers, right? So now this name is very long for us to work with, right? So in Rust, using type aliases can help simplify things for us, right? And an example of this is so okay, so I'll add a comment here. So I'll call this type aliases. So type aliases with enum. So here I can define a type, right? So I can say let's instead of me to use the very long name, I can just say type and I'll call it operation or ops and I'll equate it to the very verbose things of whatever that long name. Very so yeah, I can do this. And instead of using this long name, I'll just use ops in my code, right? So in my main function, I can now say let ops be equal to let it be equals to ops and I can get the add, right? So you can see I can get add multiply or something. So I can do this and it works. And you can even see my Rust analyzer is already suggesting that name to me, telling me that this is pointing to the very long name that I had. So the very verbose enum of things to do with numbers, right? So instead of using that very, very long name, I'll just go ahead and use the ops itself. So I'll save this, see if I'll still get all those warning. Okay, yeah. So I don't have those warning again. I just have the warning that's telling me I've not used subtract and multiply, which makes a lot of sense, right? So I can go ahead to use this in my code, right? I can go ahead to use the very verbose enum of things to do with numbers. Okay. So I just wanted to show this particular pattern in case you find yourself in a situation where you need to you don't want to use a name because it is so long, right? This is one thing you can do, which is type aliases. And basically the only advantage of this thing is just making the code a little bit cleaner. Making it cleaner, which is something everyone or anyone would definitely appreciate, right? So next, enums, um, you know, uh, can can be paired with implementation blocks to add functionality. So inside these blocks, we can use self. So that is the self keyword that would refer to the enum itself, right? So this is kind of like the this keyword in JavaScript, but more straightforward in this case, in my own opinion, right? So let's without further ado, let's just go ahead and do that. So I'll take this out because I want to use the very verbose whatever name, and I would also take this out. Oh, I'll just leave that. So I'll create an implementation block. So I'll call it impl, and I'll call it very verbose things to do with numbers. Then in this place, I'll create a function. So this function is going to take the enum, and like I said, the enum is we're going to use self. We're going to pass it as a parameter to the function. We're going to pass two numbers, so an x and a y of type i32, and this function is going to return an i32 for us. So the function is going to we're going to use pattern matching here, and we're going to add, subtract, and multiply, right? So now I'll just go ahead and declare the function. So I'll call the function run, and here I'm going to pass the reference to itself. So reference to self self. Then I'm going to take an x value of i32 and y value of i32, right? Then I'm going to return. I want to return an i32. Mhm. So then I'm going to use pattern matching. So I'm going to use match, and here I'm going to say self. Um, okay. So missing blah, 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 empty. Okay, nice. So here I will say self self add and self add, and here I want to do x because this is add plus y, right? It says subtract, multiply, not covered. Okay, I'll do the same thing for subtract. So I'll say self dot subtract. So it's going to be x subtracted from this. Then I'm going to do for the last one, which is multiplying. So just x, right? So just multiply, right? So now that we've created this implementation block, right, to do some certain things for us in our main function, we are then going to um we're then going to use that in our main function, right? So instead of having okay, so in our main function, what we are now going to do is we're going to say let's ops. So in this case, we're calling it ops because to type out that operation is too long. So we use very verbose things to do with numbers, and we would call the add function. And once we do that, just print. Let's print something, right? Let's just print print line. So we'd say the result of that. So result of this. So we'd say ops. So we want to call the ops dot run. So the function, and we'll pass two numbers there. So let's say 10, and the next one will say 5. So we should have 15 logged to the terminal for us when we do this. So I'll just comment out this line. So we're done with type aliases. This is mm, take this out, take this out from here. And so I'm just trying to make the code more organized. Put it here. Mm, no, not here. Under here, right? Okay, so save this, and yeah, we have a cleaner code base. So just to make our log cleaner, so I would comment out the inspect because I don't want to pass any value to the inspect function because I want a clean log. I'll save this and I'll clear terminal. So don't mind the error, miss the warning signs because I'm not using the inspect and all these guys are not being used. So that's why it's throwing those errors. So now, hopefully, I should get 15 because basically what I'm doing here is I had created a an enum, right? An enum that does things with numbers. So add, subtract, multiply. Then on that enum, I created added some functionality using the implementation block. So in that implementation block, I kind of wrote a function that takes a reference to itself. So it takes self, and the self in this case is the enum, right? And the enum in this case is this guy here, right? So when I did that, this function took the enum itself and it also took two numbers, so x and y, and it's going to return a number after it has done something. So in that function, I now use pattern matching, which we spoke about previously. So I use pattern matching. So in this case, like if you're coming from JavaScript, it's just like switch, like I said before. You have cases, right? So any of the cases that match what your what you need, you run that particular block of code. So in this case, self itself. So for add, we are going to add x and y. For subtract, we are going to minus. Multiply, we are going to multiply. So in this case, after doing that, after adding a functionality to our enum, we now went ahead to you know create this line where we use the enum. So very verbose, whatever stuff to do with numbers dot add, right? And we then on this particular variable, we then called the function. So the run function, so the run functionality that we had added here, right? We then called it on there. And we know that this run functionality expects two integers. So 10 and 5. So we passed 10 and 5 here. And when we run this, we should be able to see 15 as the number. Right? I know this can be a little bit all over the place to understand, but trust me, it makes a lot of sense. So I'll just go ahead and run this code. So you can immediately see that we have the results as 15, right? We can go ahead and do similar things for subtract. So if we want to subtract 10 from 5, so instead of we'll just remove the add and we'll use subtract and save. So if I do for subtraction, I should get 5 as the answer. So I'll go run. Don't mind all this warning errors. So you can see we have five because we've called the subtraction part of this guy, right? So we are calling this part. So it matched our pattern matched the line on line 95, right? So we also do the same again for 96, which is multiplication. So here, where is that place? So we'll remove this and we'll add multiply, save, play this guy, can go run. Yeah, so we can begin to see. So 10 times 5 is 50, right? So now in this case, this particular line or this particular block of our code ran. So it's kind of pretty much similar to what we did with the inspect, right? Where we passed events and we logged in. So you can begin to see how this can make our code you know more rich and more expressive, right? So next we are now going to move over to how like using the use declaration. In this case, I'll try as much as possible to not really um, you know so this particular aspect we are going into is kind of complex and not really complex, but I wouldn't want to really go so deep into it so that I don't say a lot of technical jargons. Yeah, of course this is a technical video, but then again, right? So now um use, so we have something we call the use declaration, right? So going back to documentation, so we have the use declaration. So basically, what we use it for manual scoping, right? So the use declaration simplifies our code by eliminating the need for manual scoping. It further makes enums, the enum variant or other items directly accessible in the current scope. So I'm going to explain what I mean as I go on to write the code. So I'll comment out the inspect function. I would have less warning signs in our code, similar to here, and similar to here also. Yep, I'll leave this guy. Okay. So now I would also comment this line, comment out the implementation block, and also this web event. We're not using it again. So this is it. What else? What else? Okay. I'll just comment out everything and we'll start afresh again, right? So yeah, so we have this. Okay. So we don't have any errors again. Is there any error? Any error? Hmm. Okay. So I'll add another comment here and call it um use declaration. It's just going to be called the use declaration, and I would create our main function. And yeah, so I'll just leave it at that, right? So now, in order for us to create this, so we'll define a couple of enums with two variants. So we'll start with one, so we'll call it enum, and we'll say stage, enum stage, and this stage, when, for instance, let's say you're playing a game, you have different stages. You have the beginner stage, you have the advanced, you have the intermediate. So we're going to have two stages in this our enum declaration. So we have begin, beginner, and we have the advanced, right? Um, Also, we are going to so I'll just add a comment there. So fine, um, stage enum with two variants, My spelling today. Okay. Then we'll define another enum called role. So we'll have enum, the role enum, and here we'd have a student, is a role, and we have a teacher as a role, right? So basically, same comments. Um, define the role, define the role enum with two variants, right? So now, um, we'll use like explicit imports to for specific variants. So the reason I'll be doing this is I'll be using some certain values. I'll try as much as possible to explain what I'm doing and why I'm doing it the way I'm doing it. But please always remember that we have like documentation to look back to, right? So for instance, what I'm doing is here, but I'm trying as much as possible to like explain more and add more like comments and why I'm doing what I'm doing. So you can always look back to the documentation for things like this. Okay, so as I was saying, in our main function, first of all, we want to use like an explicit import. When we want to use an explicit import for a specific variant of this page, we use something like we use the use keyword, a crate, and the stage. Then we destructure it to get the beginner and the advanced. What do I mean by this? So let's say we want to use the stage enum, right? What we'll do is we'll say we use the use keyword, which is use, and we'll pass crate. So there's a reason why we are using crates. I'll go into that later on. But in this, we'll pass the crate, and there we'll then get stage because we are currently in this scope. Then we want to get what is inside there. So we have beginner, and we have advanced, right? So and this is curly braces. So this is how we can explicit. So this is an explicit way to import for specific variants of the stage. So I'll just add that comment there. So I have it written down somewhere. I'll just add it. Um, okay. So use explicit import. So this is how we use explicit import for specific variants. So we are, you know, explicitly importing the beginner and the advanced, right? We can also do like an automatic import to kind of bring all of them into our distance. So we can do um, automatic automatic um, imports to bring all the variants into scope, right, into our current scope. And the way we can use this, we can use the flag, we can use the hash flag to do that. So we can say use the crate, and we'll do this for role. And instead of doing that destructuring kind of thing, we'll just pass a flag there, right? And yeah, so with this, we've been able to bring everything that is inside our role into this place, right? So now, we can also do something that is equivalent to stage dot beginner. So something that is equivalent to that, we can say, so instead of doing this, so equivalent to something like stage and beginner, right? We can do, in this case, we can say stage, let's stage, what is this thing? Let stage be equal to straight up our beginner, right? So we can do that because beginner straight up, right? So another thing again, so this is because of what we've done here on line 147, right? So instead of doing this, once we have explicitly imported, we can just go ahead and do this, right? We can still do the same thing for role. So the equivalent of getting the students from the role, so we can say role, and one of the roles is, we have teacher and student, so we can say students, right? And instead of doing this, we can do what similar to what we did here. So we can say let's the role be equal to students, right? This curly braces, save, right? Exactly. So forget about the warning errors. It's just because we are not using them for anything at the moment. So another thing we can do again is we can also match on the stage enum to provide specific behaviors, right? So we can use the pattern matching to provide specific behaviors for you know for each of the enums or each of the rows or each of the stages, right? What I mean by this is we can just create our match. So our match, and here we pass the stage, say stage, and in our stage we can go ahead to say so if the person is a beginner, right? So if the person is a beginner, we want to immediately print something. So we'll just say print line. I'll say he is beginner, a beginner, and the comma. I'll go to the next one. The person is advanced. You can just go ahead and say print line. He is experienced. Experienced. Exactly. So we can do this to individually match different things for each of these. And if you notice, we are not doing any kind of manual scoping, right? Due to we have already used the use declaration. And what do I mean by manual scoping? Manual scoping is similar to what we did here. So if you look at the web event dot page load, right, we did manual scoping in this place, right? So because we used the use keyword, we don't have to do that. So you can now see that this is a little bit cleaner than using than what we did here. So if I comment this out, so if I comment out the inspect, you can see that we did manual scoping here, and this is because we did not use the use keyword, right? But now that we use the use keyword here to kind of bring these things into scope, we do not have to do that. So we have a cleaner match statement. I prefer this, but it's just that it has um an extra step to it. So guys, once again, I just want to say thank you guys for joining me. I can see quite a number of people on the live. Thank you all for joining. Please, you can leave a comment on YouTube. I'm also streaming this on YouTube. And leave a comment. You can also like, share it with someone. It's the least you could do for me, and I really appreciate. Thank you. So now we've done um something similar for the stage where we got the beginner and the advanced. We can also go ahead to do same thing for the role, right? So we can match the role and we'll pass the role here. And instead of doing our manual scoping, because we've already done our automatic importation of that particular role, into the scope. We'll just go ahead and say first for students. For students, we say this is a student, and for teacher, say so this is a teacher. So see how clean it is compared to the inspect, right? Where we had to go into the enum, which is the web event, and get the page load. So if we had not done this, if we had not used the use to bring it into scope, what would have actually done here is to say role colon colon student before we write this line of code, right? That's what we would have actually done here. Same thing for this too. So basically, what the use helps us do is that it helps us prevent, makes us just write basically cleaner code, right? What we had before will still work, but any at the end of the day, whatever style of coding you choose, at the end of the day, it's entirely your choice, right? Entirely your choice. So I said child is constructed but never used. Hmm. All right. This teacher. As you saying, teacher is constructed but never used. Anyways, so let's go ahead and run this code. So I'll clear, I'll run, and let's see what we get in our terminal. Exactly. So we can see that he is a beginner and this is a student, right? And then yeah, so this is because he's a beginner, this is a student. This is because we've declared it here, right? We declared the different respective roles. Here we can also do the same thing for um, you know, our teacher and the advanced stage. Yeah, so that's why he's saying we've never used it, right? We can do that here and we'll get that log to the console. So moving forward, we also have C-like kinds of enums, right? So we have like C-like type of enums, and this C-like type of enums, um, they like the name suggests, um, you know, they are the type of enums that we adopted from like C language C, where each variant has an integer value, or sometimes it's called a discriminator. So the discriminator can be assigned explicitly or implicitly, starting at 0 for the first variant, right? So now to illustrate this, I'm just going to create an enum and I'll call it number. So enum, I'll call this number, and in here we'll just say um, 0, 1. Hmm, Trying to do this. Then we have 2. Okay. So these are like this is one of the enums, and this is I'm going to use this to demonstrate explicit sorry implicit um discriminators, right? Then would have also we also have our own explicit um would have a an explicit discriminator, and I will just paste this here in the code because that's a lot to write, right? So we have color. We have our enum with explicit discriminators. So we have red, green, and blue, right? So now in our main function, I'll just comment all this out. Our main function, I'll just go ahead and print and show um, how we can use each of them. So for the first one, enums. So it's worth to note that enums can be cast to integers using a keyword called as. Right. So I'll add that comment here. I'll say enums can be cast to integers using the as keyword. Stop. So now, um, what would let's go ahead and do that. So we'll say print line. So we'll say 0, 0, and we'll just say number. So here we are not doing any manual. We're not doing any scoping. So we're going to do our normal manual scoping. So we'll say number double colon and get 0. So 0 that is in our enum, and we'll then say as we want it to be an I32. That is an integer. So an I32 is an I32. Then we'll do the same thing for 1. Paste this here. Call this 1, and here we'll say 1 exactly. So I'll save. So if I go on and I run this code, can go run, you should see zero as one. Oh, print line, not a function. Oh, sorry. I'm supposed to. This is a macro, not a function. So I have to add exclamation marks. So guys, this is one of the amazing things about Rust. You can see how detailed the error message is, right? It's telling me that the print line is not a function, right? It's not telling me to use the exclamation mark to invoke the macro because the print line is a macro. Rust. It's telling me to invoke the macro by adding the exclamation mark, right? And it's even telling me the line whether it's happening. So line 163 and line 162. So this is one of the most amazing things about Rust. It's not even um, maybe about the other things that a lot of people talk about. For me, one of the most amazing things about the language is the helpful error messages that you can get when you're working in this kind of situation. It helps a lot. Right? Coming from a language like JavaScript, you know, it's going to be hell if you have maybe this kind of problem, right? But then again, without digressing too much from what we're talking about, I would go ahead and save this, clear my terminal, and run the code again. So you can see, and we have 0, 0, 0, 1, 1. So I can even make it better, right, by adding something like is making it a little bit readable. Clear this, run it. Okay, so you can see 0 is 0, 1 is 1. So we can do the same thing for the colors, right? So we can print colors in hexadecimal format, right? So what we can do here, so we have our colors. What we can do is we can go ahead and say um, print line, sorry, um, print line, and there we say roses are and ash, and because we are printing in hexadecimal, right? So 06x, right? So this is like printing in hexadecimal format. So I'll add a comment for that, make it more understandable of what we are doing. Then I would then use again manual scoping because remember we are not using the use keyword here, so we're not able to, we have to manually scope it. We can't have something as clean as what we had here, right? So we'll just go ahead and where's that line of code. So we say color, which is the name of the enum, and in color we want to get red, right? So red, and we'll say as I32, right? So I can save this and I'll clear terminal and I'll run that code again. So you can already see, right? Roses are this color. So I was going to implement linked list, but to take a long time, and I actually want to dedicate the linked list, the linked list part of this our live sessions to a more dedicated um, a more dedicated video, right? So um, I was going to implement a linked list using enums, but that's going to take a lot of time, and we are almost 2 hours. Like I think this is the longest I've streamed. So I will leave that for a later stream. And the way I want to do is I want to not just implement a linked list, because we know linked lists are, they're similar to queues, right? They're like data structures. So I'd want to implement that and also like show the application for linked list, like the real world application. What can we use a linked list to do? Where can we use it? An example of how we can use like a linked list is when we are all familiar with the undo and redo functionality of, even like anything that we're doing, like if you're typing something, you can undo and redo. So it uses the think is it the leave last in first out format, right? YQ uses the first in first out format, that is FIF or something like that. So in our coming streams, I would go ahead and implement um a linked list. I will do it with enums. I would also have another live session where I would then build something like the undo and redo functionality that we have in our, like something like Microsoft Word. If you're using Google Docs and all those things, where if you make a mistake, you can undo it or you can redo it, something like that. So we're going to implement that particular um, functionality. Um, yeah, so I'll just go ahead and give like a summary of everything. I'm also not going to go into constants, because constants are they are important, right? But there are things I believe if you're interested, you can just go ahead and read more about them. It's a very short chapter. I'm not really going to spend a lot of time going over the details of constants, right? But one thing to note in it is that Rust provides two types of constants, which is the const and the statics. That can be declared in any scope, including the global scope of the application or whatever it is you're working on. So both types require an explicit type annotation to define their value, right? So the const represent a constant as an unchangeable value, right? So this is the most common in most use cases. Why the static represents possibly a mutable value with hyphen and static lifetime something something and all that. So it's something that you can just go ahead and read up on. It's really not something um I would want to go into. So in summary, under enums we talked about use declaration, which simplifies our code, right? So back to the code, we talked about the use. I'll just close this out. And we talked about the use declaration. Where it starts. Yeah, so we talked about the use declaration here. Comment this out. And how it simplifies our code, right? I also compared it with the manual scoping, which we did here, where we had to manually um, call the enum. So this is the enum, where we manually had to call the enum and get the page load and all that, right? So we talked about the use declaration and how we use it to use it to reduce repetitive um, code and make our code cleaner and all that. We also looked at C-like enums, um, which provide simple constants with integer discriminators. Both do support implicit and explicit discriminators. So I was not able to go into linked list because that's going to take like another 1 hour. And so we have about 100 and almost 120 persons on the live stream. I just want to say thank you guys for joining me. It's been almost 2 hours since we've been here, and just want to say thank you for supporting what I do. No matter how small, please don't forget to drop a like, leave a comment, on YouTube especially. I really need support on YouTube. So guys, thank you so much for joining me on this one, and I will see you in the next one. Bye.